For a long time, 3I/Atlas was nothing more than a name in an old database. A quiet traveler, a frozen wanderer, a visitor from somewhere far beyond anything we can imagine. Most astronomers hardly spoke about it. It came, it passed, it faded into the dark, just like millions of other objects drifting through our solar system. Nothing special, nothing dangerous, just another rock following the rules of gravity. But sometimes, the things we ignore the most are the ones that come back to remind us we were wrong. And 3I/Atlas was about to do exactly that. It started with a routine scan, the kind that happens every night in observatories across the world. A quiet hum of machines, a faint glow of screens, scientists sipping cold coffee, waiting for numbers that almost never surprise them. But that night, something was different. A small notification popped up on a NASA monitor. A new light curve, fresh data from an object that wasn't supposed to be interesting at all. Yet the moment the graph appeared, the room went still. Because the curve didn't rise smoothly, it didn't fall gently, it didn't behave like any normal comet returning from the cold. There was a subtle shift, a tiny change, almost invisible. The kind of anomaly you'd miss if you blinked. But it was there, and once you saw it, you couldn't unsee it. It looked like a heartbeat. The astronomer who spotted it leaned back in her chair, confused. This wasn't noise. This wasn't an error. The object changed brightness in a way that didn't match any model NASA had. Comets brighten when they get closer to the sun. They dim when they drift away. They follow patterns, predictable, steady, almost boring. But 3I/Atlas was different. The shift wasn't tied to distance, or temperature, or sunlight. It was tied to something else, something the formulas couldn't capture. A presence, a rhythm, a hint that deep inside this wandering visitor, something was happening. The astronomer whispered to herself, "What are you doing out there?" As hours passed, the team gathered around the monitor. More data arrived, more measurements, more confusion. Every fresh observation pointed to the same truth. 3I/Atlas wasn't behaving like a normal comet at all. Imagine watching a person walk down a street. You expect them to move in a straight line, calm and predictable, but suddenly their steps sink to a pattern, a quiet beat only they can hear. That's what the object looked like. A traveler following a rhythm hidden beneath its frozen shell. But here was the unsettling part. The rhythm was growing stronger. By sunrise, NASA sent the data to 2 other observatories for verification. Maybe the equipment glitched. Maybe the beam caught stray noise. Maybe it was just an illusion. But the other observatories saw the same shift, the same strange rise and fall, the same quiet heartbeat. And with every hour that passed, the pattern sharpened. But no one dared to say the word, forming in their minds. Alive. No scientist wants to use that word. Not for a comet. Not for something drifting alone in the dark for millions of years. But the data didn't care what made sense. It wasn't here to protect our comfort. It was here to tell the truth, even if that truth made our skin crawl. Soon, whispers began to spread across the departments. 3I/Atlas was coming back. Not as a silent piece of rock, but as something different. Something changed. Something that almost felt aware. Its trajectory hadn't shifted. Its speed was normal. Its orbit still matched predictions. But its light, its brightness, that tiny flicker in the curve, it felt intentional. It felt controlled. And if that were true, then this wasn't just a comet brushing past the sun. This was something returning with a purpose. Days later, a second team reviewed a decade-old image of 3I/Atlas. Back then, its curve was flat, calm, predictable. The picture of a quiet, harmless object. But now, its glow pulsed like a signal, a soft wave rising in the darkness, almost like the beat of a distant heart trying to be heard. One scientist stared at the old data and whispered, "How did we miss this?" But the real question wasn't how they missed something then. It was why the object was changing now. What triggered the shift? Why here? Why now? And why us? Imagine standing alone in a field at night. The sky is silent. The world is still. And suddenly, in the corner of your eye, a single star flickers in a pattern you've never seen before. Not random, not chaotic. Almost like it's trying to get your attention. That's what NASA felt. A cosmic whisper, a quiet return. A signal hidden inside the heartbeat of a comet that shouldn't have one. The universe rarely speaks this clearly. And when it does, we're often afraid to listen. The team decided to track 3I/Atlas more closely. They pointed more telescopes at it. They gathered more data. They synchronized observation times down to the second. And with every new snapshot, the shift grew a little sharper. The light curve wasn't drifting. It wasn't fading. It was evolving. Like something waking up. Like something preparing for the next step. The object had crossed the ecliptic before, without a sound. But this time, it returned with a whisper that felt more like a warning. Something inside it was active. Something inside it was responding. Something inside it was alive with intention. As the chapter ends, the question hangs heavy in the air. If 3I/Atlas has changed this much before even reaching the sun, what will happen when it gets closer? What happens when the heartbeat grows louder? And most of all, what happens when something that shouldn't be awake finally opens its eyes? There are moments in science, tiny moments, where the universe whispers before it screams. A small drift in a number, a shift in a decimal, a fraction so small, most people would scroll past it without a second thought. But for the astronomers watching 3I/Atlas, that fraction felt like a crack in reality. Because as the object moved closer to the sun, towards its perihelion, something strange began to happen. Its path started to drift. Not wildly, not dramatically, just enough. Enough for a scientist to pause. Enough for another to frown. Enough for a third to clear his throat and say, "Can someone check this again?" At first, they blamed the instruments. Maybe the telescope calibration slipped. Maybe thermal noise distorted the reading. Maybe a simple software update could fix the entire thing. But the next scan showed the same drift. And the next one after that. And then the one after that. Small errors, yes. But errors that repeated in the exact same direction, with the exact same timing, as if the object was nudging itself off course. A whisper in motion, like a boat adjusting its sail ever so slightly. Not enough to alarm anyone on the shore, but enough for a trained sailor to know something is guiding it. As the hours passed, NASA's orbital team recalculated the trajectory again and again. Each time, the prediction shifted by another tiny fraction of a percent. The kind of change you don't feel at first. But when it keeps happening, one scientist leaned back and said softly, "It shouldn't be able to do this. Not at this distance. Not with this mass." His colleague nodded, eyes locked on the numbers. Unless something else is controlling it. She didn't finish the sentence. She didn't have to. The room already felt colder. Let's imagine it visually. Picture a long, perfect curve. The path every comet follows as the sun pulls it in. Physics loves perfect curves. They give us comfort. They tell us the universe is predictable. But 3I/Atlas had started drawing its own line. A line that didn't fit the simulation. A line that made every accurate prediction collapse. A line that felt almost intentional. Every time the team corrected the model, the object drifted again. Every correction exposed a deeper flaw. Every update brought more confusion. It was like chasing a shadow that kept stepping out of the light. Soon, scientists around the world joined the effort. From Hawaii to Chile, from Europe to India, telescopes locked onto the strange visitor. And the same whispers repeated everywhere. The speed shifted again. The angle is off by 0.02%. The projection changed overnight. These are not dramatic numbers. Nobody watching the sky with the naked eye would notice anything unusual, but the universe speaks in small clues. And the people who listen know when something is wrong. What bothered everyone wasn't the size of the errors. It was the pattern. The drift always happened after the same time interval. Always in the same direction. Always just enough to hint that something under the surface was adjusting itself. One researcher in Germany compared the shift to a silent correction, like a spacecraft making microburns to stay on course. But 3I/Atlas wasn't a spacecraft. At least, it wasn't supposed to be. The closer it came to perihelion, the brighter it became. Not because of the sun's heat, that part was normal, but because its reflectivity changed in short bursts, as if the surface was turning, revealing angles that weren't natural. Something inside it seemed to wake up under sunlight. And with each glow, the drift in the orbit grew clearer, almost like the object wasn't falling toward the sun, it was aiming toward something. By now, a quiet tension had spread through the offices. Nobody wanted to panic. Nobody wanted to say the wrong thing. And certainly, nobody wanted to suggest the impossible. So they kept the conversation safe. Maybe it's outgassing. Maybe the ice pockets are boiling off. Maybe the structure is uneven. Maybe. But deep down, they all knew. Outgassing doesn't repeat in perfect patterns. Thermal shifts don't occur on schedule, and random forces don't push an object with this kind of precision. Something else was happening. Something the models weren't built to understand. Finally, one scientist, an older man who had studied comets his entire life, broke the silence. He stared at the latest trajectory overlay. 2 lines glowed on the screen, the expected path and the actual one. They weren't far apart, but they were drifting further with every scan. He exhaled and whispered, "This isn't a miscalculation. It's a response. A response. The kind of word nobody in the room wanted to hear. Because responses come from systems, from machines, from things that make decisions, not from comets. But the real fear came from something else. As they modeled the new data, the drift suggested a destination, a point in space the object seemed to be adjusting toward. A point it shouldn't know, a point it shouldn't care about, a point that wasn't part of its natural orbit at all, like something inside it was guiding the approach. Like something was preparing for perihelion, the way a creature prepares for a deep breath before waking up. By nightfall, a private report was drafted. It didn't say intelligent. It didn't say artificial. It didn't say controlled, but the phrasing was enough to raise chills. All observed deviations imply a non-random force acting from within the object. The cause is unexplained. Unexplained. A word that sits heavy on the tongue. A word that keeps scientists up at night. A word that signals the moment when curiosity becomes fear. And as Chapter 2 closes, the question becomes impossible to ignore. If every correction leads to a deeper anomaly, if every drift reveals another hidden pattern, if every step closer to the sun uncovers something deliberate, then what will 3I/Atlas do when it finally reaches perihelion? Will the drift stop, or will it reveal something none of us are ready to see? The truth waits in the light ahead. There are signals in this universe that don't want to be found. They hide inside static. They whisper beneath noise. They wait for the rare moment when a human being actually slows down and listens. And for 3I/Atlas, that moment arrived on a quiet night when someone noticed a flicker that shouldn't have existed. It began as a mistake, or at least, that's what everyone assumed. A tiny brightening in the object's light. A strange spike, barely visible on the graph. The kind of blip most astronomers delete without a second thought. A tired researcher in Arizona saw it first. She rubbed her eyes, checked her equipment, checked again. Probably noise, she whispered. One single flash, lost inside hours of darkness. But 47 minutes later, it happened again. A second pulse, a second spike, a second breath of light from an object that never should have changed at all. She circled the spikes on her screen, two thin lines rising out of a flat desert of data. Still, she hesitated. Maybe the system glitched. Maybe the telescope's mirror vibrated. Maybe her own heartbeat synced with her hand on the mouse. But then the third pulse arrived, perfectly on time, perfectly spaced, perfectly identical. A 4-7-minute rhythm, a cosmic heartbeat. Her stomach tightened. Her hands stopped moving. For a long moment, she didn't speak, didn't breathe, because deep down, she already knew the truth. Noise doesn't repeat like this. Noise doesn't keep time. Noise doesn't act like it's alive. She emailed the data to another observatory, quietly. No dramatic warnings, no bold claims, just a single question. Do you see this too? Hours passed. Then a reply came in. Yes, we see it. Another pulse, another spike, another perfect 4-7-minute beat. Now 2 telescopes were hearing the same whisper, and then a third and a fourth. By the next morning, observatories across the planet pointed their instruments at 3I/Atlas, and every single one heard the same thing. A pulse hiding inside the darkness. Not random, not chaotic, not natural. A rhythm, a pattern, a message. Scientists tried to explain it away. They always do. Because the alternative, the idea that something inside this object was creating the pulses, was too big to face. So they blamed the equipment. They blamed reflections. They blamed math errors. But when different telescopes on different continents saw the exact same flashes, the excuses collapsed. This wasn't a glitch. This wasn't coincidence. This was a real signal coming from a real object moving through our solar system. And it wasn't stopping. Picture it for a moment, a silent wanderer drifting through space. No voice, no atmosphere, no heat, just ice and rock floating in the endless dark. And yet, every 47 minutes, a pulse bursts out of it, like a flash of breath from something sleeping under the surface, a slow awakening, a heartbeat echoing across millions of miles. Imagine being one of the researchers staring at that graph, watching the spikes rise and fall like the pulse of a distant creature. Imagine the chill running down your spine when you realize it's doing this on purpose. Eventually, the team began timing the pulses with extreme precision. 47 minutes, not 46, not 48, exactly 47. They checked the interval 1,000 ways. They accounted for light delay, for atmospheric distortion, for orbital position. Nothing changed. The rhythm remained perfect, too perfect. Nature is rarely that neat. Stars flicker, magnetic fields fluctuate, comets tumble and stumble through their orbits. But this was something else. A pattern, a countdown, a beat, like the slow blinking of a machine waking up. The breakthrough came when someone overlapped data from every observatory tracking the object, when the pulses from Arizona, Chile, Japan, India, Europe, South Africa were all placed on top of each other. They aligned. Every peak, every valley, every flash, all synchronized down to the second. Think about that. Different machines, different skies, different hemispheres, different nights. And yet, the signal never drifted, never slipped, never paused. Whatever was creating it knew exactly what it was doing. One scientist looked at the synchronized graph and whispered, "This is communication." Another shook her head. "We can't say that. Not yet." But you could hear the fear in her voice, the kind you feel when your mind knows the truth before your mouth can admit it. Because randomness doesn't behave like this. Chaos doesn't keep time. Nature doesn't follow a schedule this strict, unless something inside 3I/Atlas wasn't natural at all. A quiet panic began to spread. Not the loud, movie-style panic, not the kind with alarms and shouting. This was the soft kind, the kind that settles in your stomach and refuses to leave, the kind that makes scientists look at each other without speaking, because speaking would make it real. One question echoed through every office, every lab, every meeting. What if this isn't a comet? What if the object that slipped into our solar system isn't drifting, but broadcasting? What if 3I/Atlas didn't just enter our skies? What if it came carrying a signal? By the end of the week, the pulses grew slightly brighter. Not by much, just enough for those watching closely to notice. And with each new pulse, another mystery surfaced. The object wasn't heating up normally. It wasn't spinning normally. It wasn't behaving like anything humanity had ever seen. But the biggest question was the simplest. Why 47 minutes? Why that number? Why that rhythm? Why that pulse? Nobody could answer it. Not yet, but deep inside, everyone shared the same thought. Maybe this was the first hint, the first knock on the door, the first sign that something inside 3I/Atlas wanted attention. Something that had been quiet for years, silent for decades, hidden for ages, until now. As the chapter closes, one truth hangs in the air like a cold breath. The pulse isn't stopping. It's growing clearer, more deliberate, and whatever is creating it has only started speaking. The real question is when the message becomes clear. Will we be ready to hear it? Sometimes, the universe speaks loudest in the things we cannot hear, not in sound, not in flashes, but in temperature. In the quiet rise and fall of heat, like the breathing of something hidden. And that's exactly what scientists discovered when they pointed their thermal scanners at 3I/Atlas. A comet made of ice and dust should behave one way, predictably, slowly, passively. But this object, this silent wanderer, it broke every rule the moment its temperature began to move. The first scan seemed ordinary, cold, stable, exactly what everyone expected from an interstellar object drifting through space. But then, a sharp rise. Not a gentle warm-up from the sun's rays. Not a soft curve upward. A spike, as if something inside the object turned on. The temperature climbed fast, held steady for a moment, and then, just as suddenly, dropped again. A clean fall into the freezing dark. A perfect cycle. The scientist who ran the scan froze. Not because the numbers were extreme, but because they were rhythmic. Nature doesn't pulse like that. Ice doesn't warm and cool on a schedule. Dust doesn't regulate itself, but machines do. She ran the scan again. Same cycle, same timing, same steep rise and fall. It was like watching a heartbeat, but in heat instead of light. The pattern repeated roughly every hour. A warming, a holding, a cooling. A controlled loop. A controlled system. She didn't want to believe it. She didn't want to say anything out loud, but her eyes kept returning to the graph. It looked less like a comet and more like something maintaining its own temperature. The way engines cool themselves, the way living things rest, the way devices cycle power to save energy. Soon more thermal scans came from other observatories, different equipment, different angles, different strength. But every single one showed the same thing. A pulse in the silence. A rise, a fall, a perfect repeat. It became impossible to ignore. One researcher whispered, "It's conserving energy." Another asked, "For what?" Nobody had an answer. Imagine staring at a distant object, millions of miles away, and watching it warm itself like a hand near a fire. Imagine seeing it cool instantly, as if hiding from something. Imagine realizing that whatever is inside that object might not be passive at all. That's what these scientists felt. A mix of awe and fear, and curiosity that hurt to keep inside. Because if 3I/Atlas is just ice and rock, then why does its temperature act like a machine choosing when to rest? Let's picture the cycle as they saw it, a cold sphere drifting through the void. Silent, still, frozen. Then, a flare of heat under the surface, a glow that spreads just enough to be detected. It holds, like a breath being taken, like something waiting in the dark. Then, the heat collapses. Not slowly, but instantly, like a switch flipping off. No hesitation, no leftover warmth, no messy decay like natural systems show. Just precision, a precision that doesn't belong to space dust. Over the next few days, the temperature cycles grew stronger. Each warming phase reached slightly higher. Each cooling phase dropped to a deeper cold. The entire object seemed to be shifting, preparing, adjusting. One scientist compared the pattern to a submarine lowering and raising power as it listens for distant signals. Another said it reminded him of sleep cycles. A third, more afraid than curious, whispered, "It feels like it's waiting. Waiting for what? Nobody wanted to think about that. NASA finally brought a team together to analyze the cycles in detail. And the closer they looked, the stranger it got. The heating phases matched the timing of the light pulses discovered earlier. The cooling phases matched the object's orbital drift. Everything lined up too cleanly. It was as if the thermal cycles weren't separate anomalies, but part of a larger pattern, part of a system, part of an internal logic, something controlling itself, something regulating its own energy, something conserving strength for a moment still ahead. But the most chilling detail came from infrared analysis. When the object heated, it didn't warm evenly. One region, a narrow band along its underside, always warmed fastest. That shouldn't happen with a natural body. Heat spreads in messy, uneven gradients. It does not pulse through a clean line like electricity flowing through a wire. This was directional. This was consistent. This was engineered. Even if nobody said it out loud, everyone felt the truth settling in the room like dust. This didn't look like random heating. It looked like activation. For a moment, imagine that narrow thermal band glowing faintly beneath the object's crust. Imagine it warming, like a silent engine. Imagine it cooling the moment the cycle ends, like something trying not to be noticed. And imagine knowing that this thing, this traveler from another star, has crossed unimaginable distances, carrying something inside it capable of switching itself on and off. What happens when it finally chooses to stay on? What happens when the cycles stop being cycles and become a continuous burn? These were the thoughts scientists tried to push away, tried but failed. By the end of the week, the thermal scans formed a perfect chart of rise and fall. It looked nothing like a comet's behavior. It looked nothing like thermal vents or volatile ice pockets. It looked like a controlled system, a machine conserving energy, a mechanism warming itself only when needed. A device running in the dark, hidden inside something that pretends to be natural. And with every passing hour, the silence around 3I/Atlas felt less like emptiness and more like focus. As this chapter closes, one question hangs in the cold dark. If this object warms itself like a machine and cools itself like something waiting, then what will happen when it reaches the heat of the sun? Will it shut down? Or will it finally wake up? The answer waits in the light ahead. Sometimes the truth doesn't appear in big explosions or loud signals. Sometimes it comes in the softest flash of light, a small reflection, a shimmer, a brief moment when something reveals more than it meant to. That moment arrived when the sun finally touched 3I/Atlas. As sunlight reached the object, every telescope watching it braced for the usual. Comets brighten in messy, unpredictable ways. Dust scatters light unevenly. Ice evaporates, creating a fuzzy glow. It's a natural, chaotic process, beautiful in its own random way. But 3I/Atlas didn't respond with chaos. It responded with order. Perfect order. The moment sunlight hit its surface, its reflectivity spiked, not in a soft curve, not in a random flare, but in sharp, geometric blocks of brightness. Bright, dim, flat, bright again. Patterns. Clean, straight-edged patterns that no natural body in space should ever create. One scientist stared at the graph and whispered, "This looks engineered." The data became stranger by the hour. It snapped to levels, as if the surface was made of panels, segments. pieces. Imagine shining a flashlight across a smooth metal machine, bright when the angle is right, black when the angle is wrong, crisp transitions, crisp edges. That's what 3I/Atlas looked like. Not like a comet, not like an asteroid, like a device pretending to be a comet. One researcher tried to explain it away. He said maybe the object had smooth ice under its crust. Maybe it cracked into even faces. Maybe, but someone else rotated the model of the reflectivity spikes, and the room went silent, because the brightness blocks aligned at angles that formed geometric shapes, squares, rectangles, triangles. Nature doesn't carve cubes into comets. It doesn't lay out panels, or grids, or repeating patterns, but machines do. Reflective panels do. Heat shields do. Solar surfaces do. What were they looking at? What was the object hiding behind this mask of dust and ice? Picture 3I/Atlas drifting through the darkness, silent, cold, unremarkable. But as the sun rises behind it, parts of its surface flash, quick glints of brightness arranged like tiles on a shell. Then they fade. Then another block lights up, then another, like signals, like responses, like something beneath the surface adjusting its orientation. This wasn't random reflection. This was behavior that suggested intention. NASA called in optical specialists to recheck the results. Different telescopes, different filters, different wavelengths. Every test returned the same strange truth. The light wasn't scattering. It was reflecting smoothly, sharply, artificially. One analyst described it as mirror-like, but not in a natural way, more like polished material beneath a thin outer layer. Another said it reminded him of thermal tiles on spacecraft designed to absorb and reject heat in specific blocks. A third scientist simply stared at a screen and whispered, "Who builds a machine and throws it into interstellar space, disguised as a comet?" And then came the real shock. As the sun's angle shifted, the brightness patterns didn't just respond. They changed shape. Straight lines became longer. Exact squares became rectangles. Reflective areas slid across the surface like panels rotating beneath a skin of dust. It was like watching shutters move on a satellite. Only this one wasn't orbiting Earth. It was drifting through our solar system, pretending to be natural. But sunlight had exposed something it never expected. Movement. Movement beneath the surface. Movement synchronized with the pulse, with the orbit drift, with the thermal cycles. All three anomalies, brightness, heat, and motion, seemed to be part of one system, one machine, one purpose. Now imagine being one of the scientists who saw the brightness blocks shift for the first time. Imagine watching the reflectivity snap from dim to bright in perfect steps, as if responding to an internal command. Imagine realizing you are looking at an object that was designed, engineered, built, but built by whom? And built for what? The fear didn't come from the light. It came from the intention behind it. As the days passed, a new idea began circulating among the teams. What if the object wasn't reflecting sunlight? What if it was absorbing it? What if some of those panels were collecting energy, storing it, feeding something inside? A machine traveling across interstellar distances would need power. It would need a way to wake itself, a way to prepare. The reflectivity patterns weren't just irregular, they were functional, like solar arrays hidden beneath a thin crust, like adaptive shielding, like a system that had been dormant for decades and was only now warming up. Every hour of sunlight revealed more. The patterns grew sharper. The panels lit up faster. The brightness snapped between states like switches being flipped. No comet behaves like this. None. Not one in recorded history. And yet 3I/Atlas, this quiet traveller, was shining like a device revealing its true skin. But the most unsettling part wasn't the geometry. It wasn't the brightness. It wasn't even the movement. It was the feeling. The feeling that the object wasn't just reacting to the sun. It was responding to it. Like something waking up in the warmth. Like something recognizing the light. Like something remembering why it came here. By the end of the week, the reflectivity model was fully mapped. It showed something impossible. A repeating grid pattern, wrapping around the object like armor. Not evenly, not smoothly, but intentionally. A pattern meant to hide. A pattern meant to look natural from far away. A pattern meant to mimic a comet so well that no one would think twice, until the sun exposed its secret. As this chapter closes, the question hanging over every scientist is simple but terrifying. Who, or what, would build something that drifts through space disguised as ice and dust? And why would it reveal itself now, after so many years of silence? Something beneath that surface is preparing for something. And the light has only shown the first crack in the mask. The next chapter will reveal what happens when the object begins to move, in ways no comet ever should. Some discoveries don't arrive with noise or drama. Some arrive in the quiet, in a number so small you almost laugh at it. But sometimes that tiny number is the key that unlocks everything. And for 3I/Atlas, that number was 0.13 degrees. A tilt so small you could blink and miss it. A shift so gentle it looked like nothing at all. But for the astronomers studying the strange visitor, that small tilt felt like the moment the universe whispered, "Look closer." It started with a simple observation. A young analyst at NASA was comparing two frames of the object, images taken only minutes apart. Everything looked the same until she noticed a tiny rotation in the object's orientation. Subtle, barely there. A fraction of a degree, 0.3. She frowned, checked the numbers, checked them again, then again. Objects in space don't rotate like this. Not perfectly. Not on cue. This wasn't tumbling. This wasn't drifting. This wasn't chaos. It was intentional. But the real shock came when she looked at the timing. The tilt happened exactly at the moment the light pulse peaked. The heartbeat of the object matched its movement. And that was the moment she realized, this isn't random. Something inside it is responding. Soon, more data poured in. Every pulse brought another shift, another 0.13 degrees. Never more, never less. The object wasn't spinning freely. It was adjusting itself. Like a swimmer turning toward the sun. Like a machine aligning with a signal. Like a creature raising its head at the moment it hears something calling its name. Each shift looked deliberate, precise, almost aware. Something deep inside 3I/Atlas seemed to be waking up. And with every wakeful moment, it tilted toward the sun, as if recognizing a familiar warmth. NASA ran simulation after simulation. What force could cause this? Is it outgassing? Is it uneven terrain? Is it radiation pressure? Is the object's surface fragmenting? But all the answers failed. Outgassing is chaotic. Terrain changes don't repeat with perfect timing. Radiation pressure is too weak. Fragmentation is unpredictable. Yet 3I/Atlas behaved like none of these. Every shift was identical. Every tilt was smooth. Every movement aligned with the pulse. A pulse shining like a signal, and a tilt responding like a reply. Imagine looking at the object through a telescope, a dark shape drifting across a sea of stars, light brushing its edges, shadows shifting across its strange surface. Then, right when the pulse reaches its brightest point, the entire object tilts. Not slowly, not lazily, but sharply, cleanly, deliberately, like something inside it turned, as if to face the sun. Even from millions of miles away, the motion feels almost biological, almost instinctive, as if the object is drawn towards something or listening for something. Guidance? Instinct? Something else entirely? NASA didn't know. But the tilt kept happening. One researcher described it perfectly. It's like a sunflower that moves toward light. Except this sunflower is the size of a mountain and not alive. But what if, on some level, it is alive? Not with cells or organs, not with biology or breath, but with machinery or memory or purpose. A different kind of life. A life that doesn't grow, but activates. Teams began tracking the tilt alongside the thermal cycles and reflectivity patterns. And the moment they connected all three, their hearts sank. The brightness spikes, the heat pulses, and the rotational shifts, they were all synchronized. Not roughly, not loosely, perfectly, like the steps of a machine running a warm-up routine. Like gears turning in harmony, like components preparing for something bigger. Every time the light pulsed, heat rose, reflectivity changed, and the object rotated exactly 0.13 degrees. It was like watching a device wake up piece by piece. One scientist whispered what everyone else was afraid to say. It's aligning itself. But aligning to what? And why? Imagine the implications. This object traveled for years through cold, empty space. Silent and still. Sleeping. But now, close to the sun, something awakened. Something began responding. The tilt wasn't an accident. It wasn't a coincidence. It was a choice. A small, subtle choice made by something that should not be capable of making choices. The universe felt suddenly different. Not empty, not random, but intentional. Some scientists theorized that the object was adjusting its position to regulate heat, like rotating panels on a spacecraft. Others believed it was aligning sensors toward the sun, trying to gather light or data. A few quietly wondered if the tilt was a form of communication, a way of shaping the outgoing pulses with more control. But the oldest scientist on the team, a man who had studied celestial bodies for 40 years, said something that stayed with everyone. This isn't instinct. Instinct doesn't follow decimals. This is guidance. Guidance. A word that cuts through the room like a blade. Guidance implies awareness. Awareness implies intention. And intention implies intelligence. Even if that intelligence looks nothing like ours, by the end of the week, the tilt had repeated dozens of times. Each shift made the object face the sun more directly, like it was studying the light, or feeding on it, or preparing for some moment still ahead. The scientists watched, breathless, as another pulse rose. The brightness climbed, the thermal scan warmed, the surface shimmered, and right on schedule, the object tilted, exactly 0.13 degrees. Number more, no less, as if it heard something, again, as if it responded, again, as if it understood. And as this chapter closes, one chilling question hangs in the silence. If 3/ATLAS is shifting its body toward the sun, with intention, with precision, with awareness, then what will happen when it finally faces the sun completely? What will it do when the light becomes too strong to ignore? Will it reveal its purpose, or will it show us something we were never meant to see? The answer lies in the next anomaly, and it's coming soon. There's a moment in every mystery when all the guesses, all the theories, all the fears suddenly sharpen into one clear truth. A moment when the universe stops whispering and starts speaking. For 3I/Atlas, that moment came when the analysts broke the pulse apart and found something hidden beneath the light, something counting, something thinking, something communicating. It started with frustration. Every observatory saw the same 4-7-minute pulse. Bright, dark, bright, dark, a steady rhythm echoing across the solar system. But a few analysts weren't satisfied with the simple pattern. They believed there was more buried beneath the obvious. So they zoomed in and zoomed in again. They magnified every rise, every fall, every microsecond of brightness. They expected random, static, chaotic noise, the usual mess of natural signals. But what they saw was structure, tiny spikes inside the pulse, tiny dips between the peaks, small, repeating clusters of brightness. One analyst whispered, "This isn't noise. This is information." Within hours, analysts across NASA, ESA, and independent labs began pulling apart the pulse. They mapped the brightness changes on a timeline. They plotted the spacing between the microflashes. And slowly, a pattern formed. The pulse wasn't just repeating. It was counting. The time intervals between the subsignals weren't random. They weren't natural. They were prime numbers. 2, 3, 5, 7, 1, 1, 1, 3, 1, 7, 1, 9. Over and over again. Prime number spacing buried inside the heartbeat of a comet. Nature doesn't count like this. Nature does repetition, chaos, waves, spirals, but it does not pick out prime numbers. Prime numbers belong to intelligence, to logic, to intention, to machines. When the analysts reported the prime number pattern to their supervisors, the room went quiet. Not confused, not curious. Quiet, because everyone understood what this meant. Something inside 3I/Atlas wasn't just pulsing, it was sending a message. Maybe not to us, maybe not for us. But a message, nonetheless. Prime numbers are the universal handshake of intelligence, a signature used in countless science fiction stories. A simple way of saying, I am not random, I am not natural. I am something else. But this wasn't fiction. This was real. This was happening in the sky right now. More teams joined the decoding effort. Some broke the light patterns into binary. Some tried mapping them to waveforms. Others overlaid them on the object's rotation and temperature cycles. And what they found made the anomaly even stranger. The prime number intervals were always exact, not approximate, not influenced by distance or heat, or rotation. Every sequence was timed with machine-level precision. Imagine the cold emptiness of space. And inside that silence, a perfect mathematical rhythm, beating like a hidden heart. Bright, dark, bright. 2 seconds, 3 seconds, 5 seconds, 7, 11, 13, over and over again, almost like a beacon, or a code, or a calling card left drifting between the stars. Some analysts tried desperately to dismiss the pattern. They suggested maybe dust jets were firing on a weird schedule, or maybe thermal cracks were creating timed reflections, or maybe magnetic fields were shaping the light. But every natural explanation collapsed when compared to the precision. Prime numbers don't happen by accident. Not in geology, not in physics, not in comet behavior. If nature ever produced perfect prime intervals, it would be the first time in recorded history. A message hidden inside a comet's light? That idea scared everyone, not because it sounded dramatic, but because it suddenly made too much sense. Picture the analysts staring at their screens, lines of numbers filling the monitors, rhythms looping, intervals repeating. A heartbeat sending mathematics into the void. One analyst leaned back in her chair, hand over her mouth, and whispered, "It's counting something. But is it counting for someone or to someone?" Nobody answered, because nobody could. The breakthrough came late at night. A 3-person team realized the prime number sequence was not just repeating, it was growing. Each new cycle added another prime. 2, 3, 5, 7, then the next cycle added 11. The next added 13. The next added 17. The object wasn't sending a loop. It was sending a progression, like steps, like chapters, like a secrets meant to rise. A rising sequence of primes, coming from deep inside an object disguised as a comet. One scientist whispered, "This is intentional. It has to be." The deeper they dug, the more they realized something unnerving. The prime number pulses were tied to the object's tilt, to its reflectivity, to its thermal cycles. Every anomaly, every strange behavior observed so far, connected back to the message in the light. It wasn't just a pulse, it was a system. Like gears connected inside a machine far older than humanity. Like a device built to activate under sunlight. Like something waiting to be discovered, but only when the time was right. And that time was now. Imagine that for a moment. A silent traveler enters our solar system. At first, it appears dormant, cold, lifeless. Then, as it approaches the sun, a signal awakens. The heat rises, the panels reflect, the body tilts, and the light begins to speak, counting in perfect primes, announcing its presence, announcing its origin, announcing something we don't yet understand. By the end of the week, one final realization chilled everyone to the bone. Prime numbers are not just mathematical curiosities. They are foundations. Foundations of encryption. Foundations of code. Foundations of information transfer. If something is sending primes, it is not simply showing intelligence. It is showing structure, language, logic, design. It is showing purpose. The question now was not whether this object was artificial, but what kind of intelligence built something that can drift through space for years, sleeping, waiting, and then begins speaking in the one language every civilization would understand: mathematics. As this chapter closes, one truth hangs heavy in the air. This isn't noise. This isn't chance. This isn't chaos. This is a message. And the next question is the one none of us are prepared for. If the object is speaking, who or what is it speaking to? The answer waits in the next chapter. There's a moment in every investigation when the data stops bending and breaks. A moment when the numbers you trusted, the models you built, suddenly fall apart in your hands. For the teams watching 3I/Atlas, that moment came without warning. One simulation failed, then another, then all of them. Gravity wasn't enough anymore. The rules weren't enough anymore. Something else was guiding the object, and no one knew where it was going. It began with confusion. A quiet confusion, the kind that starts as a whisper in the back of your mind. The models predicting the comet's path were usually flawless. They tracked speed, mass, distance, solar pressure, all the forces acting on an object in space. But as 3I/Atlas moved deeper into the inner solar system, the predictions began to drift off course. Not by much at first, just a tiny sideways slide, a small shift in trajectory, something almost too small to notice. But the drift didn't stop. It grew, step by step, hour by hour. A slow, deliberate move away from the path gravity had drawn for it. It was as if an invisible hand pushed the object, nudging it in a direction no model could predict. The scientists recalculated everything. They adjusted for radiation pressure, for outgassing, for thermal jets, for the sun's gravity, for Jupiter's gravity, for Pluto's ancient pull. Nothing worked. Every model that assumed the object was natural failed. Every simulation that treated it like a comet collapsed. One analyst stared at his screen, rubbing his temples, and whispered, "It's choosing its path, isn't it?" "No," one answered, because the truth was too big and too frightening to say out loud. Imagine watching a stone roll down a hill. Gravity tells you exactly where it will land. The slope tells you how fast it will roll. Everything is predictable. But imagine that halfway down the hill, the stone suddenly turns, not because of a bump, not because of wind, but because it decided to. That's what 3I/Atlas looked like. Not a stone, not a comet, not an accident. A choice, a will, a direction. Something inside it acted, and the universe simply followed. Teams ran emergency high-fidelity simulations. Millions of paths, millions of scenarios. Every one of them broke. Graphs turned into tangled lines. Predictions collapsed into chaos. The models spiraled, trying to compute a force that shouldn't exist. One researcher described it like this: "It's moving like it has a destination." That sentence spread across the teams like a rumor too dangerous to believe, but too accurate to ignore. Because that's exactly what it looked like. 3I/Atlas wasn't drifting. It was navigating. Subtle, careful, precise. NASA eventually stopped trying to force the object into natural models, and instead ran simulations assuming the object had internal propulsion. Even then, the predictions struggled. Whatever force was pushing it wasn't constant. It wasn't chaotic. It was responsive. It adjusted with temperature, with light, with the pulse, with the tilt. A system responding to its environment, like a machine adjusting course, or like a creature moving through water, using tiny, controlled motions to glide where it wanted. No matter how the scientists framed it, biological or mechanical, the result was the same. 3I/Atlas was moving with intention. The strangest part wasn't the direction, but the calmness of the movement. It didn't speed up. It didn't burn fuel. It didn't make sharp turns. It simply leaned into a new path, slowly, silently, gently, like it didn't want to be noticed, like it didn't care about impressing anyone, like it had done this countless times before. Every shift was so small, so soft, that only the most sensitive models picked it up. But added together, those shifts created a new trajectory, a destination forming in the dark. Picture a map of the solar system, the orbits of the planets, the curves of comets, the steady sweep of gravity. Now picture a thin line, the predicted path of 3I/Atlas in soft grey. Then picture a second line, the real path, glowing red. At first, the lines touch, perfectly aligned. But then, the red line begins to drift away, just a hair, barely noticeable. Then it drifts a little more, then a little more, until suddenly, the red path breaks free from the grey entirely, heading somewhere else, somewhere gravity didn't choose, somewhere it chose. What terrified the scientists wasn't that the path changed, it was what the new path suggested. When they extended the object's adjusted course forward, plotting it years, then decades ahead, a strange truth emerged. It wasn't heading toward a planet. It wasn't heading toward a moon. It wasn't heading toward the sun. It was heading toward empty space, a point in the dark, a location with no natural significance, no star, no gravity well, no landmark at all, a place that made no sense. Unless 3I/Atlas knew something we didn't. Meetings grew tense. Nobody wanted to say the words forming in their minds. Was this a rendezvous point? A signal station? A recharging zone? A checkpoint for something traveling between stars? The more they studied the drift, the more it looked like a plan. A path created long before it entered our solar system. A destination chosen before humans ever existed. One scientist looked at the new trajectory and said quietly, "It's not lost. It's remembering where to go." Imagine that, a machine, or something like a machine, crossing the void for centuries, sleeping, waiting, drifting, until the sun woke it. And slowly, quietly, it began turning back toward its route. Like a traveler, opening its eyes and continuing a journey, it began long before we were here. By the end of the week, the phrase model collapse became official. Every natural explanation failed. Every gravitational simulation failed. Every attempt to fit the object into known physics failed. The only models that worked were the ones treating 3I/Atlas as something capable of intent, something that could choose, something that had already chosen. And as this chapter closes, one haunting question becomes impossible to ignore. If the object is moving with purpose, if it refuses to follow gravity alone, if it is navigating through our solar system, then what destination, what point in the dark is it heading toward? And more importantly, what will happen when it finally gets there? The answer is waiting in the next anomaly. In space, shadows tell stories. They reveal shape, movement, distance. They show where the light begins and where it ends. But the shadow trailing 3I/Atlas didn't follow any rule we knew, because it wasn't made of darkness. It was made of cold, a thin, chilling strip of space where heat itself seemed to disappear. The discovery came during a routine thermal scan. A scientist in Chile was mapping heat signatures around the object, checking how sunlight warmed its surface, how dust scattered, how heat traveled. Everything looked normal until he saw a faint line stretching behind the object. A narrow streak of space that was colder than it should ever be. At first, he thought it was a glitch. Maybe the sensor miscalculated. Maybe the software froze. Maybe he simply misread the image. But the more he zoomed in, the more the truth became impossible to ignore. A shadow. Not of darkness, but of temperature. A shadow carved out of cold. He alerted other observatories. They scanned the same region. And there it was again. A tail, not of dust, not of gas, not of light, but of missing heat. Like something inside 3IATLAS was sucking warmth out of the space behind it, a void trailing in its wake, a perfect negative of what should have been a glowing, heated tail. Imagine watching a comet streak across the sky. Its tail burns bright, full of dust and vapor. But now, picture a different kind of tail. Silent, dark, thin as a razor line. A place where even photons seem to slow down, where heat flees, where the temperature dives lower than the space around it. That was the shadow they saw. It didn't behave like anything natural. It bent, twisted, and shifted, as if something solid, something structured, was shaping it, something hidden inside the object. One scientist compared the shadow to a cold wake, like the trail behind a ship cutting through water. But space has no water, no waves, no fluid to push aside. So what was shaping this shadow? What was cooling space behind the object with such precision? Another scientist suggested an idea that made the room fall silent. It's not blocking light, it's blocking heat. Like a shield, a surface cooling its surroundings on purpose. But why? They tried to match the shadow's shape to the known structure of comets. They compared it to dust tails, ion tails, gas jets, electrostatic trails. Nothing matched. Comet tails spread wide. They glow. They swirl. But this shadow held its form. It stayed thin, sharp, clean, and most disturbing of all, it bent. It didn't follow the path of the solar wind. It didn't drift with charged particles. It curved like a physical object was slicing through space and dragging a cold imprint behind it. Comets don't leave cold scars behind them. Space dust doesn't carve temperature shapes. But machines do, engines do, heat sinks do, cooling systems do. One engineer, someone who had spent years designing radiators for spacecraft, looked at the shadow and whispered, "This looks like a thermal exhaust pattern." Thermal exhaust, a system designed to shed heat, to regulate temperature, to protect internal components. If the shadow was thermal exhaust, that meant something inside the object was producing heat. Heat it needed to get rid of. But that heat wasn't reaching space normally. It was being absorbed, redirected, channeled into a cold shadow. A shadow maintaining its shape, a shadow behaving like technology, not nature. As the scientists watched the shadow shift and bend, a strange idea took hold. What if the cold shadow wasn't an accident? What if it was a protective curtain, a cloak, a way to hide whatever was happening inside the object? If a machine wanted to keep itself cool, or hide heat signatures, or disguise inner workings, it would need something exactly like this. A controlled cold wake. A thermal mask, something designed to hide the truth. When the object tilted during its pulse cycles, the shadow moved with it, not behind but with. Synchronized. Connected. Like the shadow wasn't something the comet produced, but something the comet carried. A structure. A device. A mechanism mounted on its underside. The kind of thing you'd expect to see on a craft, not on a cosmic snowball. And the more they studied it, the more the cold shadow looked like a fingerprint, a signature of engineering, a hint that 3I/Atlas wasn't just reflecting strange light or tilting in perfect intervals or counting in prime numbers. It was running a system, multiple systems, systems working together for a purpose still hidden from us. But one detail frightened the researchers the most. As the object continued its slow drift away from its predicted path, the shadow began to point, not behind it, but toward the direction it was heading, like a pointer, a guide, a sign. Instead of trailing behind the comet, the cold shadow leaned forward, leading the way, as if the object was steering along a path only it understood, a path carved through heatlessness, guided by a mechanism that shaped the temperature of space itself. The shadow wasn't just a tail, it was a direction. Imagine that, a structure cooling the space ahead of it, like clearing a lane through the dark. Clearing a path towards something, or someone, waiting out there, a cold spear, piercing the blackness, a silent arrow, pointing toward the object's destination. What kind of machine cools the very space it travels through? What kind of intelligence designs something to hide its heat, mask its engine, and guide its path with a shadow of cold? Nobody had answers. Only fear, only wonder. Only questions that grew darker with every scan. As this chapter closes, one truth hangs like ice in the air. A shadow made of cold is not a shadow. It is a signature, a clue, a warning. And if this object carries a thermal structure so advanced it can sculpt temperature itself, what will happen when that structure finally reveals what's hidden beneath the shell? The next chapter holds the answer, and it is far more dangerous than the shadow behind it. There are moments in science when the truth becomes too heavy to ignore. Moments when data stops being numbers and turns into something darker, something that changes the room, changes the air, changes the people staring at it. For the NASA team studying 3I/Atlas, that moment came late. One night, when someone finally typed the words no one wanted to see on paper, possible artificial core. 3 words. Quiet, simple, but powerful enough to shake the entire investigation. For weeks, the team had been drowning in anomalies. The perfect pulse, the thermal cycles, the geometric reflectivity, the cold shadow bending in impossible angles, the tilt that behaved like a decision, the trajectory that ignored gravity. Every anomaly pointed to design, but no one wanted to say it, because saying it meant believing that something built something intelligent, something capable of engineering a machine that could cross billions of miles undetected. A machine disguised as a comet, a machine that woke up near the sun. But the truth kept growing louder, and at some point, someone had to acknowledge the shape in the darkness. The first person to speak said it softly, with hesitation in her voice. What if the core isn't natural? The room went silent. Then another scientist added, "Nothing in nature behaves this consistently." Another whispered, "Machines do." Another said, "It's responding. It's aligning. It's counting." No one disagreed, not anymore. But nobody wanted to be the one to write it down, because written words cannot be taken back. Written words become evidence. History, truth. And this was a truth too big for anyone to comfortably own. They gathered in a small conference room. 7 people, 2 laptops, 1 dim lamp flickering as if it sensed the tension. They laid out every anomaly, the pulses, the cold shadow, the reflectivity tiles, the prime number signal, the trajectory shift. One scientist looked at the list and said, if these came from a spacecraft, they would all make sense. Nobody responded, because they all knew he was right. The object moved like a craft, cooled like a craft, reflected like a craft, emitted signals like a craft. The only thing it didn't do was reveal itself openly. It hid behind ice and dust, behind a facade of nature, behind a mask. But sunlight had peeled that mask away, and now the truth glared back at them. After hours of quiet debate, one team member finally opened a new document. A blank report. No title, no header, no assumptions. Just an empty page waiting for someone brave enough to fill it. Her fingers hovered over the keys. Her breath shook. Then she typed, "Preliminary analysis, potential artificial structure within 3I/Atlas." One sentence, but it changed everything. It gave shape to the fear everyone carried. It turned whispers into evidence. It made the unthinkable official. Once the first line was written, the rest came faster. They listed the synchronized thermal cycles, matched perfectly with the pulse. They listed the reflectivity spikes, like panels shifting under sunlight. They listed the rotational shifts, the exact 0.13 degree adjustments timed with the signal. They listed the cold shadow, as if a cooling system was venting heat away from the core. They listed the prime numbers, the clearest sign of intention. Then they listed the trajectory changes, the silent refusal to follow gravity. At the end of the document, they added one more line. Behavior strongly suggests internal propulsion or active guidance. Active guidance. A phrase that made every person in that room feel suddenly small. But the question haunting everyone was simple. If this thing is artificial, then who built it? And even more terrifying, why is it here now? One scientist suggested it might be a probe sent to observe star systems. Another theorized it could be old, very old, a relic drifting long after its makers were gone. A few wondered if it wasn't here by accident, but by design. Maybe it was programmed to wake up near a star. Maybe it was scanning for something. Maybe it detected Earth long before we noticed it. Maybe it had been watching quietly, waiting for the right moment to reveal a tiny fraction of itself. A pulse, a tilt, a shadow, a message. Not enough to declare its presence, but enough to say, I am here. Someone floated a darker theory. What if 3I/Atlas wasn't here to observe planets, but civilizations? If a machine is intelligent enough to cross interstellar space, it would know what stars create life. It would know which worlds have potential. It would know how to hide until it was sure. Maybe the object didn't miscalculate its course. Maybe it arrived exactly where it intended. Maybe it wasn't drifting through our neighborhood. Maybe it came for our neighborhood. A few scientists dismissed the idea. A few didn't. But nobody could shake the feeling that this wasn't coincidence. This was timing. Timing that made too much sense. As they finalized the private report, one final section had to be written. Purpose unknown. 2 words. Cold. Heavy. True. Because, for all the data, all the logic, all the fear, nobody knew what the object wanted. It didn't transmit language. It didn't show aggression. It didn't change course toward Earth. It didn't slow down. It didn't speed up. It simply continued its silent journey, revealing just enough to be noticed. Never enough to be understood. Was it watching us? Scanning us? Ignoring us? Or was it waiting? Waiting for perihelion? Waiting for alignment? Waiting for a signal we haven't detected? No one could answer. Not yet. The team saved the document, encrypted it, locked it behind multiple clearance levels. A report no one wanted to write, but everyone knew had to exist, because the truth was no longer avoidable. 3I/Atlas wasn't just an object passing through the solar system. It was a visitor, a machine, a probe, a message, a memory from something older than us, smarter than us, farther than we can imagine. And it was awake. The only question left was, what will it do next? The answer waits in the final chapter. In every story about the unknown, there comes a moment when everything goes quiet, a moment when the signals fade, the noise stops, and the thing you were studying finally looks back at you. For 3I/Atlas, that moment arrived in the last hours before it slipped back into the outer dark, leaving behind more questions than answers, and one final flash that would haunt every scientist who saw it. By now, NASA had grown used to the object's pulse, that strange, steady rhythm beating every 47 minutes, like a cosmic heartbeat. They had grown used to the heat cycles, the geometric reflections, the prime numbers, the impossible tilt, the cold shadow bending in unnatural shapes. All of it had become familiar, even if none of it made sense. But on its last night in the inner solar system, the object did something it had never done before. It went silent, completely silent. The first sign came from an observatory in Spain. The pulse, that perfect repeating beacon of light, didn't arrive. The timestamp hit the mark. The graph stayed flat. The team froze. They waited for the next cycle. Nothing. Then the next. Still nothing. The heartbeat of 3I/Atlas had stopped. Across the world, scientists watched their screens in stunned silence as the object's once living pulse dropped into a dead, empty line. No flicker, no shimmer, no rhythm, just silence. As if whatever was inside had powered down or died. Or finished what it came to do. Minutes later, thermal scans confirmed the second shock. The heating cycles were gone. The cooling cycles were gone. The object's once dynamic surface, the mysterious thermal heartbeat that rose and fell in perfect loops, flattened into a single state. Cold, perfect cold. Not natural cold, not gradual cold. Sudden cold. Like a machine switching off. Like something choosing stillness. No comet behaves like that. But 3I/Atlas wasn't behaving like a comet anymore. It wasn't behaving like anything alive or anything mechanical. It was behaving like something finished. One scientist described it perfectly. It felt like watching a light blink out in a deep forest, right after you realized the light had been watching you. The silence wasn't peaceful. It was heavy, intentional. For the first time since its awakening near the sun, 3I/Atlas looked truly dead. But no one believed it. Not yet. because objects like this don't simply stop. Not after everything they've shown. Not after everything they've revealed. Everyone waited, staring at the data, waiting for one more pulse, one more sign that the object still lived. Hours passed. Nothing. As the object drifted toward the edge of the inner solar system, its motion slowed slightly. Not dramatically, but enough for the teams to notice. It was like a final exhale, a soft drift outward, like a creature crawling back into the dark after completing something it wasn't ready to explain. Telescopes across the world locked onto it for one last observation. Every scientist, every analyst, every person who had studied this strange visitor felt the same uneasy truth. This was the last time humanity would ever see it. And then, just when everyone had accepted the silence, it happened. A flash. A single, sharp flash of light. Not random, not soft, not like the noisy reflections of a comet. This flash was precise, intentional, surgical, and it was pointed directly at Earth. For one breathless second, the object lit up like a beacon, not with randomness, but with focus, as if the entire surface angled itself just long enough to send a message. Bright, sharp, direct, like an eye-opening, one last time. The flash lasted barely a moment, less than a blink, and then vanished into darkness. The pulse did not return. The object did not heat up again. It did not tilt. It did not move unnaturally. It simply continued drifting outward, quietly, steadily, like something that had completed its role and was ready to disappear. Scientists replayed the flash over and over again. Was it a data glitch? A reflection? A final thermal burst? But the timing ruined every natural explanation. The flash came at the exact moment Earth rotated beneath the object's line of sight. Not before, not after. At the precise second our planet was centered in its path. A moment of alignment so perfect that no natural body, no random chunk of ice could ever have planned it. Unless it wasn't random. Unless it was looking. Unless it chose that moment. Some scientists whispered that the flash was a goodbye, a farewell from something ancient and lonely returning to the void. Others feared it was a warning, a message saying, I was here, I saw you, and I am leaving now. A smaller group suggested something stranger. What if the flash wasn't for us? What if it wasn't directed at Earth, but through Earth? A signal meant to pass through our position, towards something behind us, something waiting deeper in the night. We don't know, and we may never know. After the flash, 3IATLAS continued its slow drift outward. No pulse, no heat, no shadow, just silence. A corpse of a machine carrying secrets too old for us to imagine. Or perhaps something still alive, just choosing to sleep again. As it moved toward the darkness, beyond Jupiter, beyond Saturn, its light faded. Its signal faded. Its presence faded, until it became what it first appeared to be. A speck, a dot, a traveler, a whisper from the dark fading back into the place it came from. And as this chapter closes, one question lingers in the minds of everyone who watched the object's last breath. That final flash. Was it a goodbye? A warning? A signal? Or something else entirely? The universe offers no answers, only silence. and a single truth. Whatever 3I/Atlas was, and whoever built it will return to the darkness knowing that for one brief moment in history, it was seen, it was heard, and it was not alone.